Welcome to Data Engineers Lunch number 107. Don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. Today, we will be covering a very exciting topic where we're going to explore the Apache Iceberg ecosystem. The co-organizers for this event are myself and Rahul. If you are interested in being a co-organizer, want to help get speakers, you can reach out to me via this email or through our email here. If you yourself are interested in giving a data engineer's lunch or speaking at our sister lunch, Cassandra Lunch, please feel free to reach out to me through either one of those channels as well. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, generally centered around data, and you can find out more about all the various groups and events at datacommunitydc.org. What do we do here at Data Engineers Lunch? Everything from the ingress, the egress of data, and everything in between, data processing, data wrangling, data engineering, and surrounding a bunch of interesting databases. If you're new and you'd like to say hi, what brought you here, what you hope to get out of this, please drop something in the YouTube chat. And as always, don't forget to like and subscribe, as well as turn on the notification bell, so that you can get notified every time we post a video or go live. A few rules. If you have a question, please ask it. I will be making sure that messages in the YouTube chat get forwarded to Alex at the appropriate time. Please be polite and courteous to others, and share what you know. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. We also have a burgeoning LLM and a generative AI practice, and we are here to help solve your data problems. Thanks to all of our sponsors, including DataStax and George Washington University, who helps us host live events. If you have any announcements, job offers, please drop links in the YouTube chat. If you have any meetups, hackathons, classes, or conferences that you would like to promote, please feel free to do that here. We currently have a sister lunch, Cassandra Lunch, that we host on Thursdays at noon Eastern Time. We have one scheduled for this Thursday with Sarma Paidapalli. I've seen him give a version of this talk in the Cassandra Town Hall, and I'm really excited for it. All of our videos are available on YouTube, and you can download more of our content, including this free runbook at anant.us/runbook. With that, I will stop sharing and pass to Alex.
Hey, everybody. Welcome. Once again, I'm glad to be here at Anant's Data Engineers Lunch once again. Let me get my screen shared. Here we go. But today, what I want to be talking about is exploring the Apache Iceberg ecosystem. Because in the past, I've talked about what is Apache Iceberg and the sort of amazing possibilities it brings to being able to leverage your data lake to be the center of your data gravity. And the question is, now a lot of time has passed, and the Apache Iceberg ecosystem has grown quite a bit. And now the promise of Apache Iceberg is here. You have that wide variety of tools that you can work with, a single copy of your data set, basically preventing you from having to make several copies of your data set and the costs and the complexities of all of that. But let's kind of go on. First, let me give you this QR code. This QR code will allow you to download the slides. So if you want to get the slides from this presentation, just scan that QR code and you will have the slides. Okay. And again, this will be on YouTube, so you'll be able to get back that, and I'll have that QR code again at the end. But also, let me tell you a little bit about myself and where I'm from. I'm from Dremio, the unified lakehouse platform for self-service analytics. Essentially, what Dremio is we make it easier to have a data lakehouse. Okay, the whole point of a data lakehouse is to have sort of this decoupled database where basically your object storage or on-prem storage acts as your storage layer, and separately you have your table format, how you understand tables, your catalog, how you group together those tables so different tools can understand them and be able to use like sort of different compute tools. But oftentimes, kind of managing all those pieces can be a lot. So Dremio makes it really easy to kind of bring that all together in one easy to use platform where it becomes easy as using any of your favorite cloud data lakehouse or cloud data warehouse platforms, but basically using it on top of your data lake. So basically Dremio gives you that sort of ease of use through a unified analytics, basically allowing you to connect all your different data sources in one place, databases, data lakes, and data warehouses, allowing you to curate that data into a very easy to understand semantic layer with documentation. Also with a very powerful SQL engine with all sorts of really great acceleration features and the ability to query data from multiple sources on-prem and in the cloud. And our lakehouse management features that help make managing a data lakehouse much easier by automatically optimizing your tables, automatically clean up, old snapshots, all these kind of things that normally you'd have to kind of manage on your own for the data lakehouse. We can take that burden off, make the whole lakehouse execution much easier, much faster, and a much more pleasant experience. So that's who we are, and which is why we care about things like Apache Iceberg and Lakehouse and Data Mesh, and why I spend so much time talking about these things. But we also run an event every year where we have several talks by several people all across the industry talking about these very, very same topics: table formats, data lakehouses, all that stuff. And that is Subsurface, the Data Lakehouse Conference, which will be held on May 2nd and 3rd. So head over to dremio.com/subsurface to register for that. And again, myself, I am Alex Merced, a developer advocate for Dremio. I've spoken a lot of events. I like to talk about Dremio, the Lakehouse, Apache Iceberg, Apache Arrow, all sorts of great topics that are really revolutionizing the data industry. On top of speaking at events, I put out a lot of content. I create, program tools in Python, JavaScript, and other languages. And one of the co-authors of Apache Iceberg, the Definitive Guide, which is going to be released soon. Okay, we're talking about, I think, April to right now, the slated release date for the actual physical copy. But you can still get yourself a free early copy by scanning this QR code right here. Also, the host of several podcasts. You can find all my socials and the links to everything right here at bio.alexmerced.com/data. But with no further ado, I'll come back to these QR codes a little bit later in the presentation. But if you like what I talk about today, you may want to scan them later. And let's first, before we get into the ecosystem, let's just remind ourselves what is Apache Iceberg. Because at the end of the day, to appreciate sort of how much it's grown, we have to remember, in case you're new to the Apache Iceberg world, what is Apache Iceberg? And Apache Iceberg is a table format. Essentially, it's a standard by which we can write metadata. So that way tools like Dremio, like Apache Spark, like Apache Flink can take a look at a group of Parquet files, ORC files, Avro files, look at a group of these files on your data lake and be able to look at them as a unified table and operate them with the same kind of guarantees that you would have in a database or a data warehouse, particularly for analytics. Okay, but also part of the Iceberg project is a set of different libraries to help tools adopt and build that Iceberg support. Okay, so right now there's primarily the Java like Iceberg libraries. There's also a fairly mature Python Iceberg library, and then some new burgeoning Rust and Go libraries for basically learning for building in the ability to read and write metadata in the Iceberg format. Iceberg is not a storage format, so you're still storing your data in files formats like Parquet, and you're still storing it in places like object storage like S3 or ADLS. It's not an execution engine. When you want to query Iceberg tables, you still need a compute engine, which could be something like a Dremio, an Apache Spark, Apache Flink, Presto, Trino, DuckDB. There's such a huge variety of support, as you'll see later on in this presentation. And it's not a running service. So adopting Iceberg doesn't require you to set up some other service to continuously be running that you then have to manage. It just is a standard of how you write metadata files that then these tools can access. But the way this works is that generally what's going to happen is that you're going to have your catalog, your catalog is external to your Iceberg table, but it's going to be some sort of mechanism, which could be something like Nessie, which I've talked about in previous talks here at Not That Engineer's Lunch, AWS Glue. There's a REST catalog specification. There's a JDBC specification, so you can use just any database as your catalog. But the idea is you need some sort of mechanism to track your tables. And what it tracks is where are those metadata files written to. Okay, so essentially a query engine like Dremio would just be able to go to your catalog, whatever it is, and say, hey, I'm looking for table A. It would then point to a metadata file on your object storage, Okay, and that would actually have all the high level details of the table, like what's the schema, how's the table partitioned, what are the historical snapshots of the table. And from that, the query engine can find the individual snapshot that it wants to query, which would be stored in one of these manifest lists, which then list all the groups of files that make up the particular snapshot. Each group is called a manifest. And then it can use metadata in that file to determine which manifests are relevant to your particular query based on your filters, like your wheres and all sorts of things. And then once it realizes which manifests are relevant, it can then scan those individual manifests, which will have statistics or metadata on the individual files. And then it can determine which individual files are needed to be scanned for your particular query. And then at the end, you have a scan plan, a plan for your query engine of which files to scan that represent the narrowest number of files needed to complete that query. Okay, providing you a much faster query because you're scanning less files. So essentially, that's the value that Iceberg brings to you, but that also enables a lot of other really cool features. Okay, it basically allows there to be ACID transactions, because basically what happens is that the way you know that a transaction has been completed is that that reference in the catalog has been updated. So in that case, when I go, hey, I want table A, I know which metadata file is because there's a metadata.json reference in the catalog. And that only changes when a transaction is complete and a new metadata.json is written. Okay, so that it takes advantage of the locking mechanisms and whatever tool you use as your catalog to be able to make sure that, hey, only a finished transaction can change the catalog through what's referred to as optimistic concurrency controls. But because of that, you have ACID guarantees. You can update, you can do deletes, you can do inserts, and you can do them concurrently and have those same ACID guarantees you would have in a database or a data warehouse. You have schema evolution. The schema of a table is just basically metadata. So in that case, you can update the metadata to include a new query that can then be superimposed on the data in the Parquet files without having to rewrite the older Parquet files that were written with an older schema. On top of that, you can actually track the historical schemas. So that way, when you go query a previous snapshot, it'll apply the old schema of that particular snapshot. So in that case, you can manage multiple schemas historically easy without having to constantly rewrite your data, which is really, really cool. You get that improved performance. As I mentioned earlier, basically because the metadata allows you to better understand what data are in what files before actually opening the files, you can make sure to, well, not scan files you don't need to scan and end up having the narrowest number of files you need to scan to get as fast a query as possible based on the data files you have. Okay, that doesn't mean that you still shouldn't aim to have well-sorted, well-partitioned data files, because that'll even give you more performance, but this will definitely get you as best performance as it can out of the files you have. Okay, a unique benefit that only exists in Apache Iceberg is partition evolution. So in the same way you could basically track the schema via the metadata, you track the partition via the metadata. So that means you can track the current partitioning. So and you can track previous partitioning schemes. And then every file in the metadata, we track which files were written with which partitioning scheme. So that way, when the query engine plans a query, it knows which sort of partitioning rules to apply to which data files. So in that case, you can actually say, I have data written with a month partitioning scheme and then switch to a day partitioning scheme without having to rewrite the whole table and still be able to successfully plan that query with data written to different partitioning schemes or more. Okay, and that's unique because of the way that Iceberg sort of structures its metadata. So that is really cool because, again, having to rewrite petabyte-sized tables because you want to change your partitioning scheme is not a great experience. So being able to avoid that is pretty cool. Then there's hidden partitioning. What this feature does, it makes using partitioning on the data lake much easier for the data engineer and much easier for the data analyst. How? Okay, well, let's think about how it used to work when you use Hive. If I were the data engineer, well, if I have a timestamp field, so like in this case, this table right here has a timestamp field, I may want to partition by month. The problem is the timestamp field might be grabbing like every second or even every millisecond or every nanosecond, and I don't want to have a partition for every unique value in a timestamp field. That would not help performance. You'd have too many partitions. So what you would do is you'd have to create a separate field called, in this case, a month field Okay. And I have to be aware of that. So that means now every time I ingest data, I have to make sure to take a moment, transform all the timestamps into month fields so I can fill that month value. So that makes my ingestion work a little bit more. Okay. My planning of how I'm going to partition my table a little bit more work than it normally or than it could be. And then for the data analyst, well, Hive is only aware that you partitioned it by this field. So if you query and you do a filter on this field, it's not going to help you. So if I do just the where, between these two timestamps, I'm going to do a full table scan. The only way to take advantage of the partitioning is to additionally add this month filter, which is kind of redundant, right? Because doesn't this kind of cover that same time span? So, and the thing is, if the data analyst doesn't add that additional query, they're going to end up doing a full table scan. So it's very easy to accidentally end up with a slow query, okay, which is also a more expensive query. So you end up not only losing time, but losing money, okay? So on both sides, there's just more work. With hidden partitioning, the way it works is that instead of you having to create a whole additional column, which also means more data you have to store in your data files for the Hive situation, in Iceberg, we just track that partition as a transformed value of the field, which is then tracked in the metadata. So the metadata would track the transformed values. So you're not having to have an additional column in every data file. So in this case, we have certain transforms that are built into the Apache Iceberg specification, like months, which would then take that timestamp value and then turn it into a month value, okay, that the metadata will track. And then when you do a query, so for the engineer, that's just much easier. They don't have to change their ingestion jobs. They just ingest the fields they were already ingesting. They don't have to additionally create this other field and store this other data. And then for the data analyst, they don't need the extra predicate. They don't need to add that month query. They just can query the timestamp. And since the metadata knows that the data is partitioned as a function of that field, it'll then take advantage of the partitioning in that table. So this makes it much less likely that you're going to have those expensive, accidental, slow queries. And it makes it much easier for the data engineer to execute really sophisticated partitioning. Very cool. Again, very unique to Apache Iceberg. So beyond just partition evolution and hidden partitioning, Iceberg also has a really unique benefit that it completely decouples the actual physical structure of the files from how it tracks the files, in the sense that when you in Hive, it required that you have a folder with all your files, and then all your partitions were subfolders of that. And generally, other formats kind of still lean into that. Iceberg completely decouples from that. So your files could literally be anywhere because they track the specific absolute file locations in the metadata. So this means that you can actually spread a data in a single partition across multiple prefixes in object storage to help prevent object prefix throttling, okay, which would be bottlenecks on object storage that you won't have to worry about with Apache Iceberg. Again, we're going to talk about all the read-write support that Apache Iceberg has across so many tools. A very unique thing in the world of Apache Iceberg is that you have data as code. So you have the ability to do branching and merging, not only at the table level, so built into Apache Iceberg, you have the ability to branch, merge, and tag the individual table. But also if you use a technology called Nessie as a catalog, which powers Dremio's integrated catalog, but Project Nessie is its own open source project, you can have branching and merging at the catalog level. So if you wanted to create an environment to work on all your tables in isolation, you could just create a quick branch, and now you can make all the changes to your tables that you want without actually affecting what production queries are seeing. Okay, but you're doing it at the catalog level, which enables you to use SQL to do it top and bottom. So not having to work with different complex CLI tools or writing, basically working between CLI tools and Python scripts. You can just do it all in SQL with a variety of tools really easily. Okay. And it's open. The Apache Iceberg project, basically they have public calls where they talk about the development of the project. They have a public mailing list where they talk about the development of the project. They have a public Slack channel. Every conversation regarding the evolution of the format is very public and very easy for anyone to participate in, allowing it to really truly reflect the community's needs and sort of focus on sort of the priorities that are going to affect the most people at any time. Okay, you have a wide variety of prominent contributors like Netflix, Apple, Dremio, and more. And again, I already mentioned the active Slack channel. So Iceberg offers a lot. Okay, and again, if you want to actually get hands-on with Iceberg, this is a really cool exercise you can scan here, where you'll actually spin up a lakehouse on your laptop, ingest data with Spark, and then query it with Dremio, and see how that whole experience is from end to end. Okay, and again, I'll share those QR codes again at the end. Now, when it comes to the ecosystem, let's first talk about being able to read Apache Iceberg tables. So this means being able to write some SQL, get back a result against a single copy of your table. So I can have one table that exists on sort of my S3 storage, and with that one copy of my table, all these tools can now query that table. Okay, that's pretty cool. Okay, so I have a variety of tools I can choose depending on what I'm trying to do to query the table. But what if I want to like add data, insert data, delete data, actually create tables? What tools do I have to write with? Well, you have quite a variety of tools that can write to Iceberg as well. So as you can see here, there's a variety of tools that can write to Iceberg. Okay, so that's pretty powerful. It's basically a who's who in the data space, right? Okay, but where things get interesting and where it makes it really different than other table formats, because other table formats might have a variety of tools I can read and write. Iceberg has quite a bit. But oftentimes when it comes, these lakehouse tables, they're not like a database. They're not like a data warehouse. In a database and data warehouse, you don't have to worry about optimization. The database or the data warehouse under the hood is constantly reading and writing things that we are unaware of to just make things kind of work. Now, in the early stages of these data lakehouse table formats, we had to do that. So we would have to do things like compaction, rewriting the data so that way it's sorted, so clustering the data, and doing these kind of operations to make sure the data is optimized. Okay. Now, while there's different options for each format, Iceberg brings together more than just like a single option. Okay. Oftentimes with the other formats, you generally have sort of a particular option you choose. Iceberg, because again, it has that open ecosystem, you have a variety of services and more coming out every day in this space of optimizing and managing Iceberg tables. Okay, and actually what I need to do is I need to add Upsolver to the slide, because Upsolver just released features for optimizing Iceberg tables as well. So now you have sort of 5 companies in this space. So Amazon Glue allows you to optimize tools in their catalog. Snowflake will optimize tables in their catalog. Tabular will optimize tables in their catalog, and then Dremio will also we provide automated table maintenance and cleanup for tables in our catalog, but we also provide the tool so you can do it from any catalog that connects to Dremio. Okay, so again, so you have 5 companies there. So again, I need to include Upsolver on this slide. Okay, and then next, also being able to have a catalog. Okay, and again, what's the difference between using like a database or whatnot? Having a basically catalog surfaces oftentimes give you not just a tool that allows you to track all your tables, but they're often bundled with a lot of those automated table services. They provide you with UIs to have observability into your catalog and things like that. So now what companies provide you that? Generally, the same 4 companies I mentioned before. Upsolver at the moment does not offer sort of its own proprietary catalog, but can connect to many of these catalogs. Dremio, again, we have our integrated catalog. And the cool thing about ours is that it is built on that Nessie technology I mentioned earlier. So it provides you that catalog level versioning so that we can do that branching, merging that across multiple tables. Okay, but then you got Tabular, Amazon Glue, Snowflake, all providing different catalogs and table management features. But there's really only one platform that does all of the above. Okay, plus data federation, so you can connect to different data sources, so that way you can query all your data sources from one place. Provides, so basically, again, a platform that provides you the ability to read Apache Iceberg tables, to write Apache Iceberg tables, to manage those Iceberg tables, to provide you a catalog for those Iceberg tables, provide you federation so that we can federate queries between those Iceberg tables and other data sources, and a semantic layer to curate, document, and govern it all. And the only platform that really provides you all of the above is Dremio. Okay, so the Dremio Lakehouse platform, and again, that's why it's called the Dremio Lakehouse platform, because it's really built to give you everything you need to really manage a lakehouse effectively. Okay, and essentially what Dremio does is, again, it's providing you a self-service experience, an intelligent query engine, and those next generation data ops capabilities with that branching and merging that's built into the catalog layer. But that's going to allow you to shift left Now, what do I mean by shifting left? So the idea is that if you imagine our traditional sort of way we do data, is like data sources on the left, then you have your data lake in the middle, then you have your data warehouse on the right. Well, if we can move some of the more and more of those data workloads from the right and shift them towards the middle in the data lake, well, you're shifting left. You're reducing a lot of the work you need to do because you're not doing that additional data movement. You're reducing your costs, but you're also getting your data to your consumers faster because you're reducing the amount of steps it takes to get it to them. Okay, so you end up increasing your or basically decreasing your time to insight, so it's faster to get the data to who needs it, and you're decreasing your TCO, your total cost of ownership. And actually, we just released a paper on Dremio that shows you how, and actually shows you examples of companies who've been able to reduce their total cost of ownership when adopting Dremio and being able to shift a lot of those workloads from their cloud data warehouses, reducing their costs up to like 50%. So huge cost savings. And then there's actually a recent Gnarly Data Waves, which is a show that I host over there at Dremio, where we had S&P, and they talked about how they were able to pretty much reduce their costs, their cloud bill by 50% from adopting Dremio and being able to move around a lot of, basically unload certain pieces of their infrastructure they didn't need anymore. So that's pretty powerful. And again, it does this by being able to kind of connect all your different data sources, provide you the ability to query all those data sources, including Apache Iceberg tables through its SQL Query Engine, provide you those lakehouse management features so that way you can manage those Iceberg tables, make sure that they're constantly compacted and well optimized. Okay, and again, you can easily deploy it not just through our cloud SaaS offering, but also through a self-managed offering, which basically enables you to, if you need to, deploy it on-prem or have a self-managed deployment if you need it. Okay, so, and then we can connect to on-prem and cloud sources, so allowing you to unify all your worlds. But yeah, so that's the platform that kind of provides you a little bit of everything. But still, we're not done with our Apache Iceberg ecosystem discussion yet, because again, I've been mentioning like table versioning, the idea of doing sort of branching and merging. And when it comes to that, Apache Iceberg has a bounty of riches because you have a variety of different versions of versioning you can do in Apache Iceberg. Other table formats, you only have one option, file versioning. That's it. That's with like a lakehouse. Generally, all the work is kind of done through a CLI tool. While with Iceberg, you also have table versioning that's actually built into the spec. So you can do branching and merging directly from within an Iceberg table and have branching snapshots. But that works at an individual table level. So if I had 1,000 tables, I would have to create branches for 1,000 tables. But then there's also catalog versioning that's with Nessie. Okay. And that enables you to, instead of having to create a branch for each individual table, create a branch of your catalog and then track it at the catalog version. So I can create one branch and that would cover changes across all the tables in the catalog. But all these options provide branching and merging, tagging, multi-table transactions. Again, there's a little caveat with the table, table versioning for multi-table transactions. One, you have to use the REST catalog specification, which is not all catalogs. And then two, the way it works currently, it's more like of a begin and end transaction type paradigm. So basically, you can do transactions across multiple tables, but it's across a single session. So you have to kind of like do it all at the same time. While with catalog and file versioning, they work more like Git, where you create a branch. So then on that branch, you can make multiple changes across multiple transactions, and none of those transactions are visible to production until you do the merge. Okay, so a slightly different paradigm. You can do rollbacks. You can roll back stuff. They're generally cloud agnostic, so you can use them with any cloud. Now, the catalog and table versioning are storage agnostic because they generally, like the catalog is just purely at the catalog level, so it doesn't even touch your storage. The table versioning is just a metadata detail. So in that case, it's just basically how the data is written. So it doesn't matter where the data is stored, as long as the engine that's querying it can read that storage. While the file versioning with lakehouse is built into sort of how object storage works. So it works with a variety of different types of object storage, but it doesn't work with like a on-prem Hadoop or something like that. So if you're a Hadoop shop, that wouldn't be an option. Okay. It's table format agnostic. That's only lakehouse is the only one that's table format agnostic. So catalog versioning, table versioning, that's only available to Iceberg. So again, the benefit of Iceberg, you have these again, the beauty of the Iceberg ecosystem is you have lots of choices at every level. The tools that you use, the way you version your data, who manages your data, you got options. Okay, which again, the benefit is not having that vendor lock. And the nice thing about catalog and table versioning is that it's very SQL centric. You can do a lot of the work via SQL, which makes using these methods of versioning much more accessible to less technical users, so that you can get more use out of it. And then the last topic I want to talk about is table format interoperability. At the end of the day, not everybody's going to be able to operate with just Iceberg or just Databricks or just Hoodie. But now there's a lot of projects out there finding ways to make these formats work together. So that way, when, probably a lot of people are going to have the majority of the data in Apache Iceberg, but, they might be using some Databricks. So they might have some Delta Lake. They might have certain streaming projects that they're just going to prefer Hoodie for. You're going to have this sort of long tail. So how do you handle that? Well, one way is that use engines that support multiple formats. So like Dremio, we can read Iceberg and Delta Lake, but we can also write to Iceberg. Okay, there's Databricks came out with Delta Lake 3.0, and they have a uniformat feature that basically allows you to right now broadcast your Delta Lake tables and create an Iceberg version of the metadata. There's some caveats there. It's written asynchronously, so basically, the minute that the Delta Lake table is updated and can be queried with the new data, doesn't necessarily mean that the Iceberg sort of mirror will be able to reflect that data, because it still has, because they're not, it writes the data after that first step completes. And if there's a lot of transactions, it'll batch them. So you won't necessarily have the same level of like time travel. So there are some limitations with that. Then there's one table, which is a project that came out of One House. And this is basically a tool that allows you to convert the metadata of a table from one format to another. So basically, right now it's a CLI tool. So you would just basically run this Java jar, pass it to where your original table is and what format it is, and then say, okay, here's where I want it and what format I want it in, and it'll just translate the metadata. Because at the end of the day, the data files, the Parquet files, are the same. Like at the end of the day, Parquet is Parquet. So you don't need to rewrite the data. You just need to rewrite the metadata to be in the format for whatever tool you need to talk to the data to talk to it. So these are different options that now exist in the space. Again, just expanding that ecosystem even further. Now, again, if you've enjoyed this talk, I highly recommend doing this exercise where you can kind of see an Apache Iceberg lakehouse end to end. This is another exercise. This one will be with just like Dremio, Nessie, and Minio. You can just see how easy it is to just kind of like have Dremio running on top of your object store with a Nessie catalog and have all that Git-like versioning. So that's this QR code right here. And then this will be, if you're ready to sort of deploy a lakehouse into production, that's where the QR code on the right would come into play. Again, I highly recommend, staying in touch. So follow me on Twitter at amdatalakehouse, subscribe to my podcast. You can find links to everything at bio.alexmerced.com/data. And also, again, if you want to get access to these slides, here's that QR code again. So I'll leave that up there for like 10 seconds for anyone who wants the slides, because I will give you all the QR codes. And also a reminder, go register for Subsurface. That's going to be in May. And again, it's going to be in person and virtual. So you can watch it from home. There's going to be, we usually have like 40 plus talks every year. So there's a lot of talks. A lot of them will probably cover Apache Iceberg, different types of lakehouse implementations. It's generally a really good time. And then again, if you want to leave any feedback's always appreciated. Just scan the QR code, fill out the form, and I'm glad to hear your thoughts. But with that, we'll open it up for Q&A. My name is Alex Merced.
Thank you, Alex. There was some discussion in the chat about what a good tool this seems like. Rahul noted it would be awesome if other databases just use this format, could copy from a transactional system and read it for analytics. I think that's sort of the metadata multiple partition options thing from earlier in the discussion.
And that's happening. I mean, there are different sort of databases. I think like StarRocks is an example that are now allow you to read Iceberg tables. So it'll have its same in technically Snowflake, where they have like their own internal database like storage and abstractions, but they will also allow you to access these external tables that can read these table formats.
That's really exciting. So I think one of the other things here that is just really interesting for me is the like breadth of options that you have in the data lakehouse itself. Um, and um, just the sort of core functionality of the Dremio platform in letting you sort of treat all of your data objects across a bunch of different platforms or database or table types in the same way just seems really profoundly valuable.
Yeah, no, it's really cool. When people have like sort of like, everyone, no one has their data generally in one place, so being able to kind of connect multiple spots, but then take advantage of lakehouse patterns as well is can be quite a game changer, depending on what you're doing. So again, there's
Mhm.
definitely what is your use case kind of conversation. So generally, anyone who's wondering, hey, does a lakehouse make sense for me? Definitely feel free to reach out to Dremio. We do free, what's the word I'm looking for, use case workshops, where we'll just kind of see like where you're at, and then figure out, hey, what is sort of the right thing for you, whether it's Dremio or something else. But yeah, no, it's really cool, and it's kind of like talking about the databases that can access external tables through Iceberg. Dremio is kind of taking the opposite paradigm, where we kind of start with the data lake, but then we can access your database from the outside in. So it's kind of like so instead of basically sort of box first and the box access to the outside, we're outside first, and then we can peek into your boxes to get the rest of your data, kind of thing. But yeah, it's all becoming sort of just basically a world of accessing all your data from everywhere, anywhere, because the bottom line is that you just want to go from your data to delivery to your consumers. So the less steps you can have in that possible, the better.
Well, we do have a question that came in from Prashant.
Mhm.
He says, we are using Iceberg on S3 with glue catalog. When we run compaction, new parquets are created, but old parquets are not deleted,
Yep.
basically indefinitely increasing the number of parquet files. And he was just wondering, how do we clean old parquets that are not needed for querying anymore?
Yeah, so basically the way Iceberg works is that you have a new snapshot every time, and all the old snapshots are still valid, because you might want to do time travel, you might want to query the old data. But again, over time, you start building up quite an amount of files. Okay. So then what you want to do is not compaction. So compaction is going to create a new snapshot with newly written files that are more optimized. What you want to do now is you want to expire old snapshots. So you want to determine sort of what is your policy as far as how back you want people to time travel. So, I mean, for example, let's say 90 days, right? So then what you would do is you'd run, if you're using Spark, there's an expire snapshots procedure that's available. And then if you're using Dremio, and again, both of them should be able to connect to AWS Glue to access those tables. So then you would run the vacuum command on Dremio. And what you would do is you would say, okay, hey, vacuum the table and then expire all snapshots, or anything older than this timestamp. And then basically you say, like, you put a timestamp of like let's say 90 days, and then any snapshots that are older than, let's say, that 90 days, or it could be like a week, whatever your desired time frame is, it'll expire those snapshots and then delete any files that are no longer associated. So what it'll do is it'll take a list of all the files, and then start checking, okay, is this file within any of these still remaining snapshots? If not, it gets deleted. Is this file part of any of these remaining snapshots? It probably does it in a more efficient way of that. I think it kind of generates like the list of, hey, these are the valid files now after going through all the snapshots, and then here's all the files that I have in the storage, and then deletes the delta.
Mhm.
But that's how you would do it. So it wouldn't be on the compaction. So the compaction is only going to create more files. It's just going to create better files in a new snapshot, and that new snapshot is going to be faster for querying. The expiring of snapshots is when actual files get deleted.
Okay, great. Um, Prashant, I hope that answered your question. It sounds like it's generally a combination between sort of expiring your files, and then you said instead of doing a compaction.
Yeah, so compaction is like it'll just create a new optimized version of your file. So I might have like 10 data files that could just be one.
Mhm.
So then it'll create a new snapshot that just has one file instead of 10. But the other 10 files still exist in case I query that old snapshot. But when I expire that snapshot, those 10 files will go away because they're not associated with any snapshot going forward.
Mhm. Yeah. So expiration is the short answer there.
Yes.
Cool. All right. So I think generally that is all of the questions that we have here. Thank you for everyone that attended. Thank you, Alex, for this really exciting talk. And we're looking forward to seeing you next month for another talk. And then in April, you're doing, I think it was actually referenced on here, a workshop on building a data lakehouse on your laptop.
Yep. So basically that QR code I shared earlier, if you want to do that exercise live with me, I will do that again. I will do that in April. We can all work through it together.
Yeah. All right. So thank you everyone for being here. Thank you, Alex. Any final words before we sign off here?
No, always a great time. Nice to see you again, Nick. And I'll see
Yeah.
you all next month.
Bye, everybody.